Example 4, 7.8. The cold water tap can fill a tub 1 minute faster than the hot water tap. The two taps together can fill the tub in 4 minutes. How long does it take each tap to fill the tub on its own? So what I'm going to start with is let x be the time it takes the cold tap to fill the tub up on its own. So making one of these tables can be very helpful in your application and word problem type questions where you have to come up with quadratics just to help organize all of your information. So if it takes X amount of minutes for the cold tap, then I know my hot tap will take X plus 1 because the question says the cold water fills 1 minute faster than the hot water tap. Together, they take 4 minutes. The question says the two taps together can fill the tub in 4 minutes. So I've organized as much as I've given there. Now I want to rearrange this to write it in fractions of work that's going to be completed in 1 minute. So the cold water tap in 1 minute will be 1 over however many minutes it takes. We're not sure. This one will just be a 1 over x plus 1. And 1 out of 4 minutes, so a quarter of the work will be done. Because if it takes 4 minutes to do all of the work, 1 minute I'll only be done a quarter of that work. So we're just putting that all in fractions over underneath 1. And so similarly, fraction of work done in 4 minutes will be 4 over x. And 4 over x plus 1. And 4 over 4, or just 1. Now what you want to do is take the last column, wherever you have equals to 1, where one of those values is a 1, to create your quadratic formula. So the first 4 over x plus 4 over x plus 1 equals 1. Now I can't do much work here until I have until I can cancel all of my denominators. So the easiest way to cancel denominators, if we were going to add them and keep our denominators, I would say make a common denominator, add numerators, and keep your denominator. But we want to cancel our denominators. So we figure out what would that common denominator be if we were going to add them all and keep our denominator. And instead of doing that, we want to multiply the numerators by what our common denominator would have been. So what I mean by that is I have an x plus 1, and this one's really over 1. So if I had to make a common denominator, it would have to be a combination of all of those denominators together, which would be x times x plus 1. And I don't have to really include that other one because it's not going to be there when I multiply anyways. So I want to multiply this whole thing by x times x plus 1. That way, once those values are in the numerator, they'll cancel whatever the denominator is. So I'll write that out in expanded form just so you can see that. So my first term, 4 over x times x plus 1, will be 4 times x plus 1, still all over x. My next term times my common denominator is over x plus 1 equals 1 times that will just be as is. So now you can see wherever those denominators were, those terms would cancel. That's a way. So you would find what your denominator is instead of making a common denominator, because we don't want it. The reason we're doing this is to cancel our denominator, is to multiply your numerators by what your common denominator would have been, so that everything is being multiplied by the same thing, but that way we can cancel whatever was in the denominator once it's on top. So the x is canceled in the first term, the x plus 1 cancels, and then we still don't have a denominator on the other side, which is fine. So now we'll multiply, simplify here, 4x plus 4 plus 4x equals x times x is x squared, x times 1 is x. Now this is starting to look like something we've done before. So move everything to the right-hand side where my x squared is already positive. So subtracting 8x and subtracting 4, 0 equals x squared. X minus 8 is negative 7x minus 4. So here's our quadratic. Now we would need to figure out what multiplies to negative 4 and adds to negative 7. Well, the only things that multiply to 4 are 2 and 2 and 1 and 4, and neither of those would add to negative 7. So when it's unfactorable like this, we use our quadratic formula. As soon as we can't find two numbers, it doesn't mean it's permanently unfactorable, it's just not easily. So we plug in our x equals negative b, negative 7 is just a positive 7. Square root of b squared, subtract 4 times a times c, all over 2a. So 7 plus or minus the square root of 7 squared, which is going to be 49. 4 times 1 times negative 4 would be 16. So 49 plus 16, all over 2. 49 plus 16 is 65 over 2. So here 65 is not a perfect square, so I can't get a value here. But since we're going to be solving for minutes anyways, we just need to find the approximate value by plugging that into our calculator. 7 plus root 65 over 2, and 7 subtract root 65 over 2. So those will be our two answers. So the first one, 7 plus root 65 over 2, is 7.53 minutes. 7 subtract root 65 over 2, negative 0.53 minutes. So again, in terms of time, that is not one of our answers. We can't have negative minutes. So 7.53. X was, so what we just solved for was the time for cold water only. So if the cold water takes 7.53 minutes, and we said the hot water was x plus 1, so whatever the cold is plus 1, then the hot water takes 8.53 minutes. That's how long they would take on their own. Example 5. The length and width of a rectangular sheet of paper is 8 inches by 11 inches. How much must be added equally to the length and width to double the area? So the area right now, we know area equals length times width. And if the length, we've got 8 by 11, our area equals 88 square inches. So that's right now. We need to figure out how much needs to be added on to both of those in order to double the area. So the area doubled, this times 2 is 176. So that's our new area that we want. So x is going to be the amount we add to each side. So if I did have 8, I'm going to be adding plus x times 11 plus x equals double the area, so 176. So we're solving for x. What do I need to add on to both of my dimensions in order to get 176, which was double the area of my sheet of paper originally? So let's FOIL that out. 8 times 11 is 88, plus 8x plus 11x plus x squared equals 176. Again, it's easier to work with your x squared value being a positive, so it's already positive on the left, so I'll subtract my 176, bring it over so that I have it equal to 0. X squared plus 19x, just combining like terms here. Subtract negative 176 plus 88 will be negative 88 equals 0. So then we are left to find two values that would multiply to 88 and add to 19. Again, you don't have, if you know something right away off the top of your head, go for it, but there's no whole numbers here in this situation. If you're ever not sure, feel free to use quadratic anytime. So x equals negative b plus or minus the square root of b squared, subtract 4ac all over 2a. Negative 19 plus or minus the square root of, when we simplify that, I get 713 all over 2. Again, simplifying here, there's not much to really do, so just enter that into your calculators. What values would you get? Negative 19 plus root 713 over 2, and negative 19 subtract root 713 over 2. So my two answers that I got when I do that is 3.85 and x equals negative 22.85. So again, this is the length we're adding on to increase our area. So I can see right now this is going to be our reject answer. We're not going to add on a negative length in order to double our area. So that means we're adding on 3.85 inches to both dimensions. Your assignment here is on the bottom, page 436, numbers 3 to 9. Once you're finished that, and you're feeling pretty good about all the sections, you can write your Chapter 7 quiz. But please come see me so that we can go over any questions you have on any of those sections, just to make sure you're feeling more confident before you write that.